All right, let's just jump right in. For a while now, we've all been talking about artificial intelligence and Web3 like they're two completely separate revolutions, right? One's creating this new kind of mind, and the other's building a totally new kind of internet. But what if they're not separate at all? What if one is actually building the body, and the other is building the world for that new body to live in? Today, we're going to explore how these two massive forces are about to converge in a way that might change, well, everything. So, to really get this, we first have to challenge a huge assumption most of us have about AI. We kind of think of intelligence as pure software, just an abstract algorithm that could run on any old computer. But there's a much more radical idea gaining steam, that real intelligence is completely inseparable from its physical form. The hardware isn't just a container for the intelligence, it is the intelligence. That's the huge difference between thinking of intelligence as software versus intelligence as substrate. And this one shift in thinking, it's kicking off a full-blown intelligence revolution. We're starting to move beyond the limits of silicon and realizing that the physical stuff intelligence is made of, it matters a lot. Now, what's really fascinating here is how this whole idea is grounded in pure physics. As the philosopher Paul Thagard puts it, you can't process information without using energy, and you can't have energy without some kind of physical material thing. This isn't just some abstract philosophical idea, it's a basic law of the universe. The material you use to think actually determines how well you can think. And this table just lays the problem out perfectly. Look at the human brain. Your brain runs on about 12 watts. That's less power than a dim light bulb. Meanwhile, the massive data centers running our big AI models, they're guzzling megawatts of power. So why the insane difference? Well, it's the architecture. Your brain's memory and processing are all mixed together. Our computers, though, are constantly shipping data back and forth between memory and the processor, and that creates a huge energy bottleneck. Our wetware is just a fundamentally better, more efficient substrate for intelligence. So the conclusion is pretty obvious. To build way more powerful and efficient AI, we need to build better substrates. And the solutions that are popping up are starting to look a whole lot more like biology. You've got neuromorphic chips like Intel's Loihi 2 that literally mimic the brain's structure. You've got synthetic biological intelligence, where actual living human neurons are grown on silicon chips. And then there's the really wild stuff, organoid intelligence, basically wetware as a service, using tiny lab-grown brain organoids to do the computing. Okay, so hold that thought about new bodies for AI. Because at the exact same time all of this is happening, a second parallel revolution is going on. We are totally rebuilding the physical infrastructure of our world, and it's all being driven by Web3. And the key concept you need to know here is DePIN. That stands for Decentralized Physical Infrastructure Networks. Now, forget all the crypto speculation for a second. Think of DePIN as a brand new economic model that uses token rewards to get regular people and businesses to build and operate real-world infrastructure together. It's a way to literally crowdsource the physical backbone of the internet. So how does this actually work? It's surprisingly simple, really. First, you contribute some kind of hardware to a network. Could be a 5G hotspot, a solar panel on your roof, or even just the spare computing power from your gaming PC. Second, that hardware provides a real, verifiable service, like giving someone wireless coverage or running an AI job. And third, you earn token rewards for doing it. It's simple, it's powerful, and it scales like crazy. And get this isn't some sci-fi theory, it's happening right now. Networks like Helium are building out decentralized telecom grids. Fuse Energy is creating community-owned power grids. Projects like Render and IO.net are crowdsourcing the massive amounts of GPU power that AI needs. And networks like Grass let you monetize your unused internet bandwidth to help gather data. DeepIn is building the physical world piece by piece from the ground up. Okay, you with me? So on one hand, we've got a new kind of intelligence getting a new kind of biological body. And on the other hand, we have a new kind of physical infrastructure being built by the crowd. This is where our two stories collide. This is the great convergence. Let's start with the most basic need of all. These new biological and neuromorphic AIs are super efficient, yeah, but they still need power. How are you going to provide reliable, distributed energy to a global network of intelligent devices? The answer is DePIN. By building these community-owned, decentralized energy grids, DePIN can provide the exact kind of resilient, local power that this new generation of AI is going to demand. You're basically matching decentralized intelligence with decentralized energy. Okay, next problem. Intelligence needs to learn from the world. It needs food. And for AI, that food is data. Massive, unbelievable amounts of real-time, high-quality data from physical sensors. So, Where's all that going to come from? Well, again, DePIN provides the actual sensor networks to collect it all. But just as important is this movement called decentralized science, or DeSci. Think of DeSci as the rules of the road for creating open and verifiable data marketplaces. It lets people and devices contribute data fairly and transparently, creating this rich, constant diet of information that these intelligent systems desperately need. And finally, think about this future world. As these AI agents become more and more autonomous, they're going to need to interact with each other. They'll need to buy and sell data, compute power, and energy. How do they prove their identity? How do they transact in a true machine-to-machine economy? This is where decentralized identifiers, or DIDs, are an absolute game changer. You can think of a DID like a digital passport that isn't issued by any government or company. It's a way for every single person, every device, and every AI agent to have its own sovereign, cryptographically secure identity that it controls completely. It's the key that unlocks a true autonomous economy for machines. So, when you put all of these pieces together, the physical DePIN layer, the DeSci data layer, and the DID identity layer, what you get is something totally new. You get a sovereign infrastructure. It's almost like building a global, self-organizing nervous system for the world. And what's truly amazing is how these components don't just work together, they actually make each other stronger, creating this powerful feedback loop. This matrix kind of shows how. For example, DePIN gives AI affordable compute power, and DIDs give DePIN a way to verify its contributors. All these pieces lock together perfectly to create a system that's way, way more powerful than just the sum of its parts. So where does all this lead? What's the end game here? What are the ultimate implications when this substrate and this network finally converge? Let's go all the way back to that central idea we started with. In biological systems, the algorithm is the substrate. The thinking isn't some abstract program running on the hardware. The thinking is the physical process itself, unfolding in real time. We're not just building smarter software anymore, we are building smarter matter. And that brings us to one last pretty fascinating question. For years and years, we've been focused on this goal of building intelligent machines. But by weaving this new kind of substrate intelligence into a decentralized physical network of energy, data, and identity, maybe we're building something else entirely. Maybe the real endgame here isn't just an intelligent machine, but an intelligent world.